Hi again, good morning. Thanks for the early visit. We'll discuss, I would say, a new topic today, something that we don't see as ordinary Java developers. But still, the interest is rising, and it really is a development area. Debug of your native images. Well, who I am? I'm an OpenJDK developer and speaker. My name is DMITRY CHUYKO, and I work at a company named BellSoft that creates many different things, but mainly focused on Java. We provide the most complete Java experience with all Java versions and GraalVM assemblies. So we also have our own Java-optimized Linux called Alpaca Linux, and I will show a bit of it today. And the distribution of OpenJDK that we release is called Liberica JDK, and the distribution of GraalVM is called Liberica Native Image Kit. Yeah, we participate in development of both OpenJDK and GraalVM, and kind of very significant. We like containers. We like small containers. That's one of the reasons why we created Alpaca Linux, to be efficient and to save some resources in the cloud deployments. So what's about GraalVM? Well, it's still a buzzword. As we preliminarily discussed before the talk, the technology is around for many years, but it's still considered new. There are some great advantages and convenience when you don't take a separate JDK runtime with you. You only have a native binary that has combined special runtime and your application and all your libraries in one single platform native executable. And it can be easily deployed, started. And sometimes it saves your resources such as memory consumption, and it can give you better performance in some cases, or comparable performance, I would say, in all cases to a regular OpenJDK. Besides, we have instant warm-up because we don't have to JIT compile the code that has been compiled ahead of time. And the startup is almost instant, right? So we start the code at peak performance and we continue to work at peak performance. So it's a great choice for the cloud. And working in the cloud brings some additional complexities that we will try to see today. So I will show simple examples, but we'll keep in mind how it may work in the cloud, in your cluster deployments, with your containers, and what it will cause on what should you be aware of when you prepare such deployments, and especially if you work with the vendor of your GraalVM distribution. Yeah, who here owns a pet? Really? Only two of you? Oh, three. Okay. And who is aware of this application? Many more people. Yeah, we know what it is. It's probably the most famous example of a microservice or Spring Boot application or Spring application. It's Spring Boot Pet Clinic. And it doesn't really matter what application to take as an example, but just to show you some data, some numeric values, some complexity amount, this application is fine to do it. So instantly, just two numbers. We can create a jar, an executable jar of it, a fat jar, and it only takes 57 megabytes on disk. But it requires a JDK to run, which typically adds another 100. So it's 157 megabytes or 160 megabytes container. And it's a layered image. Or you can create a native image from this application. The size varies if you create native executables using the same version of the compiler, but for different platforms, the difference may be like tens of megabytes. We'll see it today. But for such applications, the size of the resulting binary is way higher than the size of the jar file. But we don't need a separate Java runtime. We just deploy this binary on top of something very lightweight, like Alpaca Linux, just base variant without any JDK thing. So let's start with looking at this application and how I used to work with Java applications. Just let's start it and try to debug it. In some case, I might need some help from the audience, like it's early in the morning. So this is just a normal terminal. A lot of letters here, but let's see what happens really. So I start Java process and I set debug options, right, including port, I limit memory, and basically that's it. I can run this application. And the embedded debugger, the debugging agent, is ready to accept connections from any debugging clients. Well, let's start such a client. Oh, let's first check the application. It's the early morning demo. Does it work? No? What's wrong? Because the port is wrong. Hooray! We got it working. So let's also connect our debugger, as we used to. Not the IDE one, but the real one. The one that we always have with our JDKs, JDB. Not too frequently used. I'm not really a frequent user of it. But that's what we always have, and that's an essential tool, and we really can do it. I'll use some helpers here. Let's look at it. So we've started it. Yeah, let's go to owners first. Right, it's owners. Owners. We'll look at this page today. And we can see some owner here. George. Okay. Here's George. So let's proceed. And I have this nice line. So we have this class. And this is the controller for that endpoint, right? And it has some obvious and famous methods, like show me an owner. And we're going to breakpoint in this method. And we are going to change its behavior. So first let's start with doing that. Are we here? Oh, what's wrong? I know what's wrong. Because we need a proper syntax. Show owner. It says nothing. That means it has found already defined class with this full qualified name and this method. So this is a breakpoint in an existing code. Yes, this is very basic debugger, so we won't be able to kind of reload code and do some other sophisticated Java stuff like extended watches or some complex expressions. But it allows us to do such things. Can we continue from here? Oh, can't, probably. What's the continue command here? Who knows?
Nothing suspended.
Nothing is suspended. Yeah, but there must be a continue command. Can't. Okay. Okay, it's running. Yeah, it's George. Okay. Oh, we have hit the breakpoint. You see? Here's our thread. Sorry, let's just resize this window a bit so you could see it. Is it okay now? So this is our stop thread. and we can examine what do we have here. In particular, we have some local variables. We resolved it. Yeah, it's Java. We know everything about this code being executed. So let's hack it. Oh, this command that I remember. So George was it? No? No white space. Okay. Why no white space? Is it? Let's check it. Locals. Yeah. All right. White space is ignored. So now cont. Yeah, it works now. Does it work? Oh, yes. Exactly. We changed yours to Betty. Hooray. That's the task that we are going to perform on our real production. So we're going to analyze what happens inside our methods. Sometimes we want to change data. Sometimes we want to go to data actually stored somewhere in some objects. Yeah. So that's kind of simple, right? We have made it. This debugging solution works for ages. Yeah, so just to remind you. In general, think of 3 major components of the process of such development and debug. We have our major host, where we users sit. It might be rather plain machine, not too powerful. There's a build machine that works with actual sources, like in real production, right? And it's able to perform complex and different builds to do actual heavy lifting. And during that builds, we produce many artifacts. We produce sources, we produce binaries, not just in case of even of a native binary, not just a single binary, but also some SO libraries. So we have a compiler there. And we have the target machine, where we actually execute all this code. And we are going to debug this target from our host. And this is, again, it can be same or different machine. It can be same or different CPU architecture. It can be same or different operating system. So they're all different, right? Especially if you use regular Java, right? And you deploy your bytecode. If you only deploy bytecode, it's Java. You compile it once and you run it everywhere. But any of them can be combined on a single host, on a single machine. In a very simple case, we create a hello world binary, native binary, or Java binary, and we compile it on the same machine, and we profile it on the same machine while we run it on the same machine. But that's not the case in production. And it never happens in production. So in production, we always have at least 2 machines, 2 different ones. So when we create, when we perform a debugging process, we control it from our host and we control our target. We need some channel, we need some protocol while we do debugging. So in the previous example, we used JDWP protocol. So we're built-in Java standardized one when we have any Java host having this client, debugging client. It can be an ID or it can be JDB. And this host can be a developer machine, or it can be something in the cloud, or it even can be the same machine as target, right? If we SSH there. But they still use the same protocol. And we control what happens, how we set that breakpoints, how how we change that variables. Of course, in case of native programs, there will be a different protocol. The JDB is the most popular one, and we will focus on it today. It's also called debug adapter. I think so. The official name probably of the protocol is debug adapter, and JDB is just an implementation. We can't just expose any ports, any channels on our production, right? We need a secure channel to go there. Either we SSH and perform some tasks, or we do it in Kubernetes, or we just proxy the traffic. So we must have a tunnel. And this tunnel should also be secured. So it will be inside SSH VPNs, maybe some other means. I don't know, floppy disks sent by airmail. And I already started talking about difference between Java executables, Java deployments, and native deployments, right? So in Java code, we have all the debug information with us. Who actually ever stripped any debug information during their deployments? Thank you. No, not thank you. Okay, you have a permission to do it. You're also a JVM developer. But we never do it in Java, right? When we prepare our bytecode, we have all the debug information with us. When we prepare our Java runtime platforms, we don't strip debug information from standard modules. We don't have libraries without debug information in the Maven Central. So we carry all the debug information. This is the default in Maven. We can actually switch it off. I will show you a small example, by the way. But please don't do it. We need to debug our applications. And that's the main way of doing it. Just please debug your normal Java applications, because that's the way we should debug our business logic, because it's easy, it's instant. You saw we just started the application, started the debugger, it works. We don't need to wait for some minutes or tens of minutes for the completion. In native world, we have one single binary, like in the case we are going to discuss today. And it has different sections in it. And it can have debug information. We can strip it after the binary has been created. That's not something supposed to be done with Java bytecode or jar files. But with native things, that happens. And we have different formats of binaries for different operating systems. There's different native code inside, right? Because it's targeted to different CPU architectures. There are different debug information formats. So Dwarf is the main here, and I will talk about this format today. Not really in great details, but just to mention it as a major format. So we take a native image. Yeah, who, by the way, already tried native images? Oh, about 50%, maybe less. So a quick overview, right? We take a slightly different SDK. We have the same Java code, like in today's example. We just take the same Spring Boot application. It's already prepared to be compiled into native. We just change the way it's being assembled, and we take the different result. We take that native binary. And for that native binary, right, we have to provide that information for debugging. And it has to be implemented for each and every platform. Well, we have multiple targets in GraalVM currently. We have Linux, Windows, and macOS. There are two CPU architectures, Intel 64-bit and ARM 64-bit. So what happens there? The most covered platform is Linux x64. No wonder, because it dominates in our productions today. But as you probably heard in different talks here, AR64 on Linux is also important in many clouds. Actually, in all major clouds, there are their own ARM64 hardware. And this is a good choice if you want to save some costs in a cloud. So it's important. We typically run Linux there and there. And it has great GDB debugger. So we'll see it in action. Windows support. There's some support for creating Windows debug information. But as been said, it's still under development, not too active development, I would say. But the macOS support was totally missing up to the recent time. So here we stepped in and created an implementation based on the Linux one. We generalized some dwarf bits across Linux and macOS for this format. So it's already available in our assemblies, and the PR is an open PR in GraalVM repository. So you can build your own version of GraalVM and include it there. On macOS, we have actually the different main debugger, LLDB, which also can be applied on Linux, but it's expected. And there's also old GDB versions on macOS, which we can try. Not sure if we need to do it, but just for the record. There are many different tasks that you may want to perform in your debugger, right? We are used to Java debuggers in our IDEs. They are so sophisticated, they are so convenient. We can really execute some complex code inside the debugging sessions. Well, native debuggers are simpler at some point, though they really provide you much stronger means to work with your actual memory and actual instructions, registers. We'll try to do it again in a few minutes. But all basic things, they really work now, especially if you run it on 64-bit Intel on Linux. And there's a good reference on official GraalVM site. There are different materials. It's basically information from there. What do we need to have that debug information in our native image? Well, it's a static compiler. It's a ahead-of-time compiler. So we have to provide some compilation options to create the debug information. Please, native image tool, when you compile our native image, create debug information for us so we could debug it. So we need to put that -G. It's also recommended to put zero optimization, no optimizations flag, though it might be not so obvious which level of optimization do you need. So by default, it's 02. Well, and if you debug native image, that means that something is wrong. And frequently, something is wrong with the platform. And if you just compile it differently, like with 00 or 01, your problem may be gone. Maybe that's the solution, and you don't need to debug. But it gives you a better view, better local information during the debug if you disable optimizations. But you can still keep it. You just need to put that additional source level debug flag. You can also keep local symbols that will provide better information for other tools that use debug information. Because debug information is used not only by debuggers, but by other tools as well. Like what? Profilers, yes, like perf. And we can get that information from that local debug symbols. That will help us to attribute code. It's just a small addition in size, but a great use. Also, when we generate debug information, we also need to provide something for our debugging host. What is it? Remember that picture with 3 boxes. We need to provide sources, because when we debug, we want to actually follow our stream of code execution looking at sources. That's the thing of debuggers that are not just CPU native debuggers, right? We want to debug our application. And the source may change. So when we compile, we must assemble all the sources and keep it as a build artifact. Or we can provide the same sources by other means, kind of semi-manually, right? But this is the thing that we need, and this compiler is able to collect all the sources. We can add source paths, right? So this is a source of sources and sources of sources. We can denote multiple folders or jar files or zip files where our sources are located. And all of that will be collected into debugging for cache root. By default, it's just sources folder under our build folder. I will show that in a moment. So let's look at some Mac machine. What do we have here? I've created a native image, and it can be run on a macOS machine, well, a bit oldish and virtual one, but still. And we can access this machine from our host, which is a Linux machine. And on this host, yeah, we can just SSH here. We can try to see what's up, what's here. We are in the target folder. I have saved some previously generated artifacts for you. So yeah, here you see we have that sources folder, and for this application, it contains like 22,000 different class sources combined from GraalVM, JDK, and your application classes. But in my configuration, actually, I was too lazy. Not from your framework classes. Let's look at the pom.xml file. So if we look here, can it be made? Oops. So in this example, I keep it O2. I say, please collect sources and create debug information, right? I don't put any sources, additional sources of sources here. So we have created some. And let's compare what's in the result. So this is the shell connected to that Mac machine. And you see, here's the original jar, 57 megabytes. Here's the release version of the native image, 212 megabytes. Here's the debug version, 509 megabytes. So here inside the native image, we have platform classes, we have application and framework classes, and debug information for all of them. And we can strip debug information using native strip tool. And we'll have this variant. And by the way, that also proves that the layout of of a native image with debug support is slightly different, but this slightly, sometimes it's not slightly. It's different from the release version. Yeah, and it's funny, we can actually put a Maven, we can put a Java-C option to strip debugging information to the Maven plugin when we create regular jar. But it will only strip or not create debug information for our application code. All the frameworks, all libraries that we use are still packed as is, containing their debug information from the Maven Central. Okay, so let's probably run something. Do we already run? No. Let's run it. Oh. I have it here. So let's start the application, but we start it on a different platform. The port, oh, sorry, it's already in use. Okay, we already run it. So let's launch LLDB. You see, I use sudo. In fact, it's possible to provide some call sign information to run it without sudo, but that's not easy. Sorry, and I need to figure out what's the PID. Let's check it. Repeat. Yeah, we have it running. We'll start the debugger and we'll attach to the running process. If I remember it correctly. Whew. Wow, it works. So we stopped our application. At debugging, you see some assembly instructions. Nice, I like it. We debug Java, right? And we look into assembly code, but we can step through the individual instructions. And yeah, let's continue. Process resuming. And we can try to create a breakpoint. But first, we need to find the method to create a breakpoint. So you remember our method is called showOwner. Let's find it. Let's look up in the native image. Wow, it has a great name, right? Okay. Breakpoint set dash n. Oh, maybe it works. Oh, I know that LDB. So we have the breakpoint in that method, and this machine traffic is proxied to the port, I guess, 82. Oh, right, it works. Owners, find owners, find owners. So, again, let's go, no, let's be smart. Let's put a number which doesn't exist, right? Nothing happens, and probably we're stopped in the debugger, right? You see here, it's a bad combination of Alt LLDB and O2 debug, O2 optimization level. So the source attribution is wrong here, but believe me, it works on the more modern systems. But we still can expect many things, like that, right? We really like it when we debug Java applications. And I actually knew it in advance. You saw the number, and I know the number in hex. it can be a slightly more sophisticated number. So typically in Java, we use coffee baby and other constants like that. But it resides in this register. So this is the parameter of this method. And we are going to change it.
Can you show a stack trace from where we are?
Yeah, I hope it won't be too poor. Yeah, we can do backtracing.
Can you show the DOM?
It's not a big Spring application, right? Okay. I don't remember the set command, but let's find it. Just okay. Register right. You see, RSI. So let's get back to that nice lady instead of the wrong number. Whoo! Hi, Betty. Works. All right. So that's all to be on Mac. And there's a better support, especially if you're new on Macs. But one of the reasons why I have used that full optimization level, because it actually needs to create less debug information. And build which creates debug information takes more time, more memory, more resources. So that was kind of just barely fitted this machine. But it was a success. All right. So what we have seen? I've took GraalVM Native Image kit. I created native image using native compilation from Maven. Barely changing the project, just putting debug native image options. And we have that debug binaries, and we have sources, and we can debug. Yes.
If you create debug info, or if the native image tool creates debug info, why can't you use the logical name? Why do we have to use the manual name for setting the breakpoint?
It is probably if I'd keep that additional local information, I could breakpoint there, but that's not a real source point. I'm not sure.
You should be able to use the Java source file location.
All inconvenience goes when you use low-level tools, when you don't use GUIs, right?
What's written there is symbols written there you can use. So what you
Yeah, let's look here. Sorry. But this is in any case, this is how it works under the hood. So we really access that symbol. That's a real dwarf symbol in that binary. Okay. Now I have a special joke. So we are going to talk about containers, and I'm going to run them in a Docker, and we're in London. So in London, you should run double Dockers. Okay. Good morning. So I'm going to run some Dockers. We'll see how it goes. So it's my first. Oh, oops.
You have to exit the debugger.
Yes, you're quite right. So here, I'm inside the Docker container. This is an Alpaca container, specially prepared to compile my application and to run it. And I'm going to provide an agent, right? Because GDB server exists. I can provide an agent to debug it from the outside. The outside, the host will be my machine, my Linux, not Alpaca, Ubuntu in this case. I'm going to connect to this container through the network. So I just start the application normally. No additional options, right? So this is the debug binary compiled for Linux x64, Muscle, by the way. So we provide assemblies for Muscle, and this is Alpaca based on Muscle C library, which is smaller. And here's another session to the same container. Right? and we see that pet clinic running. And I'm going to start a GDB server, an agent that accepts connections from debugging clients to debug. So I denote the PID of the process here. So I'm starting here. And this port is forwarded to my machine from Docker, right? It can be as well forwarded using Kubernetes means, like kubectl port forwarding. So I, as a developer, can attach my GDB to that remote service. That's what I'm going to do. I start GDB. Oop. Oh, continue without paging. And I'm going to connect to that kind of remote machine, right? Where is it? Where is it? Where is it? Sorry. So I lost it. Probably it already. Oop. Maybe it already has connected. Let me check. Oops. Oh, target remote. I have it on the slide. All right. We connect, and then I compiled my application. I created all the source bundles, so I connect from the place where has it also same sources as on my target machine. I actually don't need sources on the target machine. I need them on my host, and I create them on the build machine. So we're here. Enable debug and yeah, probably. All right, we are attached to the process. Let's perform the same task. Let's find this function that finds owner, that shows owners. It takes some time, and that's not the worst machine I can get. And the binary is kind of huge. Okay, we have found it. Let's set the breakpoint. So probably it should stay like this. Yeah, it is better. In GDB, it's better. So you'll see it will find, it correctly shows my source file. LLDB, modern LLDB also correctly shows the source file. And it will show the source to us. So I've created, I can continue. So the process is forwarded, the port is forwarded to, yeah, here. Fine owner. Oops. And let's do the same trick, right? So we can go here. We're stopped. Oops. Stopped. Hit breakpoint 1. Here's my information. I can step, for example, right?
You don't have the source file.
Maybe I just likely made some wrong selections here. Anyway, let's go to the favorite part. Oh, locals. Info locals, I get. Oh. Where's our owner ID? I know the answer. It is here. So here's our owner ID. That's not the right syntax because it's incomplete, but it should work anyway. We have changed it. We can continue. And hello, Betty. All right. That was JDB.
Like on your slide, you mentioned that you can show objects.
Yeah.
Print objects. So how can you print?
So it's interesting. The major point here is that Java objects are represented as C++ objects. So this debug information gives you overview of the inheritance. It can allow you to inspect fields, to follow references, and
How can I just see the fields of this object?
let me show just a quick thing here. So you see this asterisk here. So it's a reference. So the object looks like a reference to a structure or a class.
How can I see the fields of owner controller? I mean,
As for C++ objects.
can you show it?
Let's just go to the last demo because, yeah, we don't have enough time. So, tired of command line? I am. That's why I'm not going to show it. There are plugins for different IDs, and they do different things. In fact, there's also a project that wraps the native debug information, native debug protocol, and pretends to be a Java application, and it exposes Java debug protocol. But it hasn't been updated for 2 years. I'm not sure how stable it is. There are pros and cons in different solutions. I will show you the one that works. Which one? Okay, no guesses. Eclipse. So we'll start favorite ID for Java. And we have a project here. This is a Java project with Maven support. And I've also installed C++ debugging support here. And for this project, I have added so-called nature. What is it? Properties. Project natures. You see, it also has C++ nature. Very convenient. That's a project that contains Java sources, only Java support, and it has debuggers. And I have a debug configurations. Oops. No, sorry. It was here. No. Debug configurations, yes. And you see, I connect to the to remote. I will show you. I'll connect to a remote target. Currently local host, right? But it can be forwarded anywhere. So we're going to catch this application. Oops. Just a moment. Oh, sorry. We need to detach, and we need to restart the JDB server. And now we need to debug. Not so easy, right? Not so integrated. But at least now we are inside the IDE. Hooray! We actually have hit the breakpoint, which I previously set here. And we can use all the steps. We can inspect locals, etc. with this nice integrated GUI without knowing any assembler. So for example, debug, right? Let's show there's some inspections. Variables. Okay, anyway, we have 1 minute left. I've just shown you that it stops. We can change owner ID there as well in the GUI. That's the major point. Okay, it works. Here's a small cheat sheet how to tune it. Just keep it for your record. So all you've seen is a hardcore, right? Not a daily job of a Java developer. But you can try it at home. It already works. Things don't break too much. And you can use your IDEs. But actually, that's a hint what you need to provide to your support vendor. What information, what access do you need to provide when you work with such technology to actually debug your native images, not your project. Thank you. You can find more technical stuff on our blog. Please visit it. And we can have a couple of questions afterwards, like right now. Thank you.